stop scrolling for a second, because the largest black hole ever discovered is so massive, it makes our entire solar system look like dust, and it shouldn't even exist. When most people think of a black hole, they imagine something big, dark, and dangerous. Maybe a few times heavier than our sun. Maybe even a few million times heavier, like the one sitting at the center of our Milky Way, Sagittarius A*, which has about 4 million times the mass of the sun. But what if I told you that astronomers have found a black hole so enormous that Sagittarius A* looks microscopic next to it? Meet TON 618, currently one of the largest reliably measured black holes ever discovered. Its mass is estimated at around 66 billion times the mass of our sun. Yes, billion, with a B. Let that sink in. If you replaced our sun with TON 618, its event horizon, the point of no return, would stretch so far that it would swallow not just Mercury, Venus, Earth, Mars, Jupiter, but extend well beyond Pluto. In fact, its diameter would be over 390 billion kilometers across. Light itself would take weeks just to travel around it. And here's the twist. We didn't even know it was a black hole at first. TON 618 was originally cataloged in 1957 during a survey of faint blue objects. At the time, astronomers had no idea they were looking at something extraordinary. Later, in the 1970s, scientists realized it was actually a quasar, one of the brightest and most energetic objects in the universe. Now here's where it gets wild. A quasar isn't just a bright object. It's powered by a supermassive black hole actively feeding on enormous amounts of gas and dust. As material spirals inward, it heats up to extreme temperatures and releases staggering amounts of radiation, often outshining entire galaxies. TON 618 is one of the most luminous quasars ever observed. It shines with the light of roughly 140 trillion suns. Think about that. One object, outshining entire galaxies. And at the center of that blazing inferno of radiation sits the monster itself, a black hole tens of billions of times more massive than our sun. Now here's the controversy. Black holes aren't supposed to get that big. At least, not easily. According to standard models of galaxy formation, black holes grow over time by merging with other black holes and by accreting matter. But growth has limits. There's a balance between gravity pulling material in and radiation pushing it away, something called the Eddington limit. So how does something grow to 66 billion solar masses without blowing away its own fuel supply? That's one of the biggest mysteries in astrophysics. And TON 618 isn't alone. In 2018, astronomers studying the galaxy cluster Phoenix discovered evidence suggesting its central black hole could be around 100 billion solar masses, though that estimate is still debated and less certain than TON 618's measurement. Other giants, like the black hole in Home 15A, are estimated at around 40 billion solar masses. So we're not just talking about one cosmic accident. We're talking about a class of ultramassive black holes that challenge our understanding of how the universe evolves. Now let's zoom out even further. TON 618 is located about 10.4 billion light-years away. That means we're seeing it as it was when the universe was less than 4 billion years old, less than a third of its current age. And that's another problem. How did something so massive form so early? The universe simply didn't have much time. To reach tens of billions of solar masses in just a few billion years, the black hole would have needed to grow at extreme, almost continuous rates, or start from an unusually massive seed. Some scientists propose that instead of forming from the collapse of a single massive star, these giants may have formed from direct collapse black holes, enormous clouds of primordial gas collapsing straight into black holes without first forming stars. If that's true, it changes how we think about the earliest structures in the universe. But here's another pattern interrupt for you. Even something this big is not dangerous to us. Black holes don't roam the universe like cosmic vacuum cleaners. TON 618 is over 10 billion light-years away. And even if it weren't, black holes only affect objects that get very close. If our sun were magically replaced by a black hole of equal mass, Earth would continue orbiting almost exactly as it does now, just without sunlight. Black holes are not cosmic monsters hunting you. They are gravitational objects obeying the same physics as everything else. But their scale? That's what breaks our brains. The Milky Way itself is about 100,000 light-years across and contains hundreds of billions of stars. Yet the black hole at TON 618's core contains more mass than 15,000 Sagittarius A*s combined. And despite its unimaginable size, the singularity at its center, the point where density becomes infinite according to general relativity, may be smaller than our solar system. That's the paradox. Something with the mass of tens of billions of stars compressed into a region smaller than a planetary system. Now here's where things get even more unsettling. Ultramassive black holes like TON 618 may represent a transitional phase in galaxy evolution. Quasars are typically active during periods of intense growth. Eventually, when the surrounding fuel runs out, they quiet down and become dormant supermassive black holes, like the one in our own galaxy. So what we're seeing might be a brief but violent chapter in a galaxy's life story. A feeding frenzy, an era of cosmic excess, and then silence. The James Webb Space Telescope is now helping astronomers peer deeper into the early universe than ever before, discovering extremely massive black hole candidates that formed surprisingly soon after the Big Bang. Some of these early findings are already forcing scientists to reconsider how quickly black holes can grow, which raises an uncomfortable possibility. Our current models might be incomplete, because when the universe produces something 66 billion times the mass of our sun, earlier than expected, shining brighter than entire galaxies, you don't just shrug and move on. You rewrite textbooks. And yet, for all its scale and fury, TON 618 is just one object in a universe estimated to contain hundreds of billions of galaxies, each with its own central black hole. Statistically speaking, there may be even larger ones out there. We just haven't found them yet. That's the humbling part. Every time we think we've reached the limit, the biggest star, the largest galaxy, the most massive black hole, the universe quietly reveals something bigger. And it forces us to confront a truth that's both thrilling and terrifying. We are studying a cosmos that is under no obligation to be reasonable. TON 618 doesn't just stretch our imagination. It stretches physics, formation theory, and our sense of scale. So the next time someone tells you space is empty, remember this. Somewhere out there, 10 billion light-years away, is a gravitational abyss 66 billion times heavier than our sun, blazing with the energy of 140 trillion stars. And we only found it because it happened to shine brightly enough across cosmic time for us to notice. If discoveries like this blow your mind as much as they blow mine, make sure you follow for more deep dives into the most extreme objects in the universe. Now I want to hear from you. If TON 618 exists, how big do you think the largest black hole in the universe really is?